So in the log variable, we saw that there was a clear violation of mutual exclusion. Okay, although the concept was very simple, but there was a violation of mutual exclusion. So after that, we came up with an idea of turn variable. Turn variable, there everything was perfect, but at the end we saw the progress was getting violated. There was mutual exclusion, there was bounded waiting, but the end progress was getting violated. And moreover, turn variable, it was a single variable, okay, which was being shared by both the processes. And this time, rather than single variable, we will use two variables, okay. We will use two variables and we will see whether the problem that was there in the turn variable, has it been solved or not, okay. The problem, that is progress. So let's see here, I have written the code. So here you see, I have used two variables, interested 0. Here I have used interest variables, okay. Interest variable means what? It will indicate whether a process is interested to enter into the critical section or not. So it is basically an array. So don't worry about array, not much concept is needed. So you just think it as interest of 0 is equal to false. Interest of 0, it indicates the interest of a process P0, okay, and interest of 1, it indicates the interest of a process P1. That's why I have written here 0. 0 means what? P0. 1 means what? P1, okay. And you see here, these both are initialized as false, okay. Interest 0 is equal to false, interest 1 is equal to false. Now you see, the codes are written for both the processes P1 and P2. And now we will analyze this code and we will see whether there is any mutual exclusion, then progress, all these things are not. Okay, so let's analyze the code. So now suppose here you see, yes. So let's see whether mutual exclusion is there or not. Okay. Now you see here, suppose here both the processes are interested to enter into the critical section. Okay, then both the process will run. So here you see, non-critical section, it's a non-critical section code that is not required, while 1. Okay, so now process P1 comes here and you see here, so since process process P0 is interested to enter the critical section, so process P0 will run the code, okay. So process P0 will run this line, then this line, and now this line. Interest 0 is equal to true. It means what? Process P0 is interested to enter inside the critical section. That's why interest of 0 is equal to true, okay. Now after this, suppose there is a context switch at this point. Okay. Now let me write here one thing. Suppose if both process P0 and process P1, both are interested to enter inside the critical section, it means what? The interest of both are true. Then what will happen? You see here. So what I said, yes. When process P0 is interested to enter inside the critical section, before process P0 could execute this while loop, context switching happened. Okay, and now CPU is given to process P1. So just remember, initially the interest of 0 was false, but since process P0 is interested, that's why here interest of 0 is equal to true. Okay, actually it's an entry section code. Okay, it's an entry code. So since process P0 is interested, so definitely process P0 will execute this while loop. Process P0 wants to break this while loop. After that, it can enter inside the critical section. But before process P0 could execute this while loop, context switching happened at this point and CPU is given to process P1. So now you see what will happen. Process P1 suppose is also interested to enter inside the critical section. So process P1 will execute this line, and now this line. Interest 1 is equal to true. Interest 1 is equal to true. It indicates that process P1 is interested to enter inside the critical section. Okay. Now you see. And also one thing, if interest is false, then it means what? Process is not interested to enter inside the critical section. So here you see, process P1 has made the interest, that is interest 1 is equal to true. So process P1 is also interested. Both are true. Okay. So since now both are true, so suppose process after executing this line, now process P1 enters in the process P1 will execute this line. This is an entry section code. Okay, this line. Process P1 wants to break this line to enter into the critical section. You see whether process P1 will be able to enter inside the critical section or not. Here you see while interest 0 is equal to true. So while interest 0 is equal to true, let's see. Here you see interest 0 means what? Instead interest 0 is equal to true means what? Here it's P1 is checking whether P0 is interested to enter inside the critical section. So yes, P0 is interested to enter inside the critical section. Here you see I have written P0 is true. Here P0 has made the value of interest as true. So since P0 is interested to enter inside the critical section, that means what? This condition is true. Okay. Since this condition is true, so while loop will not be broken. So P1 is stuck in the while loop. Okay. P1 can't enter inside the critical section. Okay. Now suppose a CPU is given back to process P0. So process P0 has already executed this line, interest of 0 is equal to true. Now process P0 will execute this while loop. Okay. So in the while loop, a condition is checked, interest 1 is equal to true. It means what? The condition is checking, that is whether process P1 is interested to enter inside the critical section. And of course, yes, you see here I have written P1 is true. It means what? Process P1 is also interested to enter inside the critical section, and moreover you see process P1 has executed this line, interest 1 is equal to true. Okay. So it means what? It's a true statement. Process P1 is also interested to enter inside the critical section. So since it is a true statement, so while loop will not be broken. So here P0 is also trapped in the while loop. So here you see, when both the processes are interested to enter inside the critical section, then what will happen? None of the process could enter inside the critical section. If both the processes are interested, then no one can enter. So here you see critical section is remain vacant. Critical section is empty. So it means what? You just tell me whether there is any progress. No, not at all. In progress, you see definitely at any time, at least one process should be inside the critical section. But here you see no process is there. So progress is not there. So here I write. Here I write here. Is it visible? Okay. Progress is not there. Okay. So when both are interested, progress is not there. So let's check about mutual exclusion, whether mutual exclusion is there or not. Now suppose, let me rub this. Now suppose if only P0 is interested and P1 is not interested. Okay, if P0 is interested and P1 is not interested, then you see what will happen. Since P0 is interested to enter inside the critical section, so P0 will execute this line, and here you see P0 will make the value of interest as 2. Interest of 0 is equal to true. It means what? P0 is interested to enter inside the critical section. Okay. And after this, you see P0 will execute this while loop. While interest of 1 is equal to true. So now here you see I have written false under P1. It means what? P1 is not interested to enter inside the critical section. So that's why interest of 1 should be false, because P1 is not interested to enter inside the critical section. So it means what? This condition is false because interest 1 is true. Interest 1 is false, but here is written interest 1 equal to false, equal to true. It means what? False is equal to true. So this condition is false, so while loop will be broken. Since while loop will be broken, so now P0 could enter inside the critical section. Okay, so here you can see when P0 is interested, then P0 can enter inside the critical section. Not only P0 is interested, here P0 is interested and P1 is not interested, then only P0 can enter inside the critical section. Okay. And let's see whether there is mutual exclusion or not, whether when P0 is inside the critical section, then P1 can enter inside the critical section or not. Let's see. Now suppose at this point CPU is given to process P1. So process P1 wants to enter inside the critical section. So you see process P1 will run this code. After that process P1 will execute this line, and here you see process P1. You see process P1 will execute this line, interest of 1 is equal to true. Okay, interest of 1 is equal to true. It means what? Now P1 is also interested to enter inside the critical section. So after this process P1 will execute this line while interest of 0 is equal to true. So this condition will be checked. It means what? Whether P0 is interested. Obviously P0 was interested. That's why P0 got the entry inside the critical section. So since this condition is true, here you see, yes, since this condition is true, that then while loop will not be broken. Since while loop will not be broken, so P1 is stuck in the while loop. P1 could not enter inside the critical section. So from here, you just try to understand one thing, that a process, if a process is interested to enter inside the critical section, then it can only enter inside the critical section if other process is not interested. Okay, you see here P0 could enter inside the critical section when P1 was not interested. Okay, when P1 was not interested, then P0 could enter inside the critical section. And when P0 entered inside the critical section, and after that suddenly P1 had a desire to enter inside the critical section. So P1 also got interested to enter inside the critical section, but since one process P0 is already inside the critical section and moreover it was interested, so now P1 can't enter. It means what? Process P1 could enter inside the critical section only if process P0 was not interested. Okay. Again I tell you. Suppose you and your friend, okay, both want to enter in a house. Okay, both are interested to enter in a house. So you can enter in a house only if your friend is not interested to enter in that house, or vice versa, your friend can enter in a house only if you are not interested to enter in a house. Okay, fine. So these things are happening here. Okay, so here you see P1 is stuck in the while loop while P0 is already inside the critical section. It means what? Mutual exclusion is there. So now when P1 can enter inside the while loop, if P0 is not interested, then only, just now I told you, If P0 is not interested, then only P1 can enter inside the while loop. So suppose the task of P0 is over and P0 comes out from the critical section. Before that, P0 will execute this line. Interest 0 is equal to false. This is an exit section code. Interest 0 is equal to false means what? Now P0 is not interested to enter inside the critical section. Since P0 has completed its task, so now P0 is not interested. So since P0 is not interested, okay, since P0 is not interested, so here I will write false, because now P0 is not interested to enter inside the critical section. Okay, and since P0 is not interested, so now P1 can enter inside the critical section. How? You see, interest of 0 is equal to true. So interest of 0 is actually false. Why? Because P0 is not interested. So false is equal to true. It is a false statement. It is a false statement means what? This while loop will be broken. Since this while loop will be broken, so now P1 can enter inside the critical section. Okay. So you see, when P0 is not interested, then only P1 can enter. So here you see, I have written false under P0, which indicates that P0 is not interested, and true under P1. It means what? P1 is interested, and since P0 is not interested and P1 is interested, so P1 has entered inside the critical section. Fine, simple, and yeah. And suppose if both the processes are not interested to enter inside the critical section, okay, then what will happen? If both the processes are not interested to enter inside the critical section, then actually we should not check this condition, because here both the processes are not interested to enter. Okay, so this condition will not be checked, because if processes are themselves not interested to enter, and moreover both the processes are not interested, then that's not important to analyze that condition. Because if the processes are not interested, then they will not enter inside the critical section. It means what? Their task might have been done. Okay, so we will check up to this point. So here you can see mutual exclusion is there. Definitely mutual exclusion is there, and also you see one thing, whether bounded waiting is there or not. Here I write bounded waiting is there or not. Let's see whether bounded waiting is there or not. Suppose you see here P0 is interested to enter inside the critical section. So now interest of 0 is equal to true. Okay. And okay. So now before entering inside the critical section, process P0 will execute this line while interest of 1 equal to true. Okay. So suppose for the time being, process P0, process P1 is not interested. Okay. Process P1 is not interested and process P0 is interested for the time being. Okay. Since process P1 is not interested, so process P0 can enter inside the critical section. Okay. Process P0 can enter inside the critical section because P1 is not interested. Here I have written interest 1 is equal to false. Now suppose suddenly process P1 also wants to get the entry inside the critical section. So for that, process P1 will run this line. After that, process P1 will run this line, interest of 1 is equal to true. It means what? Now process P1 is interested. Okay. Now process P1 will run this line while interest of 0 is equal to true. So obviously it's a true statement because interest of 0 is true. Okay. And P0 is interested to enter inside the critical section, although it has already entered inside the critical section, but still interest of 0 is equal to true. So since this condition is true, so P1 will P1 will stuck in the while loop. Okay. It means what? P1 is waiting for the condition when P0 is not interested to enter inside the critical section, so that this condition will be false, and after that P1 could get the entry inside the critical section. Okay, so let's see what will happen. Now suppose the task of P0 is over. Okay, so P0 will execute this line, interest rate of 0 is equal to false. Fine. So P0 has executed this line, interest of 0 is equal to false, which indicates that P1's task is over and P1 is not interested to enter inside the critical section. So after the execution of this line, P1 came out from the critical section. Since P1 came out from the critical section and moreover interest of 0 is equal to false, that is P1 is P0 came out from the critical section, and since P0 came out of the critical section and moreover the interest of 0 is equal to false, so this statement is false, so P1 can enter inside the critical section. Okay, but before P1 could execute this line again, after coming out from the critical section, P0 suddenly again got an interest to enter inside the critical section. So P0 will again be made as true. Okay, and P0 will again be made as true. Yes. Yes. Now P0 is again interested to enter inside the critical section. So now interest of 0 is equal to true again. So now after this P0 will execute this line, interest of 1 is equal to false, is equal to true, and here you can see that interest of 1 is true. So now P0 is stuck in the while loop. Okay, and here you can see that P1 is also stuck in the while loop. Why? Because although the interest of 0 was made false by P0, okay, but before P1 could execute this while loop again to enter inside the critical section, P0 again came and made the interest value true. So again it was made as true is equal to true. So P1 got stuck in the while loop again. Here you see both the processes are interested at the same time. That's why both the processes are stuck in the while loop. So it means what? Bounded waiting is not there, because here you see process P1, when process P0 was executing, process P1 was waiting for the process P0 to come out from the critical section. After that, process P1 can enter inside the critical section. But actually what happened? Even when P0 came out from the critical section and before P1 could execute this while loop again to enter inside the critical section, P0 again made this variable interest of 0 is equal to true. So again now that P1 couldn't get the entry inside the critical section. So here P1 is waiting infinitely. Okay. Although here both the processes are stuck. So here you see bounded waiting is not there. Moreover, you see busy waiting is there. Okay. Busy waiting is there. Okay. And also one thing is, you can see that, you see, suppose you see both the processes are interested to enter the critical section at the same time, then what will happen? Both the process will stuck in the while loop. Why? Because If P0 is interested to enter inside the critical section, then interest of 0 is equal to true, and P0 is interested to enter inside the critical section, interest of 1 is equal to true. So here you see the condition of while loop is true. So now both the processes are stuck in the while loop. So both the processes are stuck in the while loop and they can't come out from this condition. So this condition is called deadlock. Here both the processes can't get the entry inside the critical section. Okay. And why they can't come out from the critical section? Because why they can't come out from this condition? Because in order to break the while loop, one process must have to enter inside the critical section and to run the exit section code. But none of the process can enter inside the critical section and run the exit section code. Okay, so both the process are stuck in the while loop forever. So here we can see that deadlock. Here I write deadlock is there. Okay, so this was all about. Okay, and after this we will study about Peterson's algorithm. Okay, and in Peterson's algorithm we will see that all these problems are solved. Okay, thank you.